Okay, I'm going to look at problem number 19 from chapter 8. What this is that it's a thin plate and it has different temperatures on each of these sides. Okay, and when this plate has these different temperatures, what you're going to notice is the grid, and you're breaking up the grid into a certain number of smaller elements. And what will happen is that, the temperature of like this point here, of course, is going to be something between these two, right? Whatever the temperature of this side is and the temperature of this side. And what you'll see is there's going to be like a linear change in temperature. So let's say if this is on this, let's say if we do just two sides and maybe this is 100 degrees C and this is 50 degrees C, what you would see is that, this is going to be a little lower than 100, a little lower than 100, lower, 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 until you finally get down to 50 degrees C. And the way that's calculated, or the way we would go and calculate that, um, is we take a point here, and with that particular point, whatever point it is on the grid, we look at the four adjacent squares. So, like if you're looking at this point right here, you're going to look at the temperature of the four adjacent squares. So, you're going to look at here, 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 and here. Okay. And this one is going to be the average of those four, right? So, what we need to do is go and iterate through all of these points and iteratively calculate the average temperature of the points that are around it, and they'll change as you go along. They'll change go along, and what will happen is that eventually the changes as time goes on and the number of iterations go on. What you'll find is that the transient or the temperature change or that delta will decrease. Okay. Now, what we can do is we can actually put a value in there to say like keep going until the change is less than like zero point 0.1 degree or something like that. Okay, and then we can say at that point we reached our equilibrium. All right. So what do you expect? You have this metal plate, whatever temperature it's at. I don't know. We'll pick a temperature maybe to start with, uh, and you hook the whatever it is, some source at the different temperatures, and eventually this will reach equilibrium. Okay, so that's really the problem. What we're going to do here is we're going to just calculate. We're going to start with some temperatures, and you're actually going to prompt the user for these. Start with some temperatures around the edges, and then we're just going to go through iteratively, go through each one of these elements, and then we're going to calculate the new temperature by being the average of what the temperature is around it. Well, if it's this one, then it becomes, whatever temperature you apply over here, whatever temperature you apply over here, the temperature of this grid, and the temperature of this grid, right? We're going to average those, and then we come up with a new temperature. Then you go to the next one, and you do the same thing. This one, this one, this one, and this one, and find the average of those. Okay, and that becomes the temperature here. And you just go all the way down the row, next row, next row, next row, next row, and next row, and you keep, and then once you do that once, um, you can compare it each time you do it to see whether or not it's over some tolerance. If it's, if all of them become like less than zero point 0.1 degree, then we can say, oh, okay, you're done, and that's in equilibrium. Okay, and that's pretty much what we're going to do here. So continuing with this, here's problem 19. Okay, so we're going to write model the temperature distribution, except we're going to use 6 rows and 8 columns. Okay, and the user enters the temperature on all 4 sides. Okay, and then use the grid to store the temperatures, of course. And then when a point is updated, a new value is used to update the next point. Okay, which we'll do. So each point essentially is a grid, an element in that grid. Continuing updating points, moving across the rows until the temperature difference for all updates are less than user entered tolerance value. Okay, and that would be whatever you use. I'll probably start with like 0.1 to start with it. The only thing is we're not going to use a vector class for this one. Okay, I'm going to do it just with an array. All right, because we didn't really cover vectors in this class. I'll make a note of that. Okay, I'm going to walk you through Chapter 8, Problem 19. So here's the standard include IOStream. I have also included CMath because I needed the ABS function, absolute value function. to use absolute value function. Okay, so that's for the absolute value function, which we'll use a little bit later here. And this is for the double data types. Okay, you'll need CMath. I think C standard lib for the integer types. Okay, here's my using namespace. And the problem actually calls out for an array 6 by 8. So here's my constants for the row size and the column size as defined by the problem. The next thing I did is, here's my function prototype type. And this is a function that actually goes through and performs the calculation, right? The averaging function. So this is averaging function, okay? Now the way I did it was that, you know, it returns, what it will do is it'll perform like one iteration of the averaging, and it returns a Boolean value, and that Boolean value is actually just whether or not we met the tolerance, okay? So I'll say one iteration, return true or false. Oh, return true if over tolerance. Okay. So if it's over tolerance, it returns true. And then essentially I use that to tell me to keep going, to do it again. Keep iterating, keep running this function again, and you'll see that. Okay. So here's the array that stores essentially the temps of the grid. Store temps of the grid. Okay. Now I didn't say like what my temperature scale is, Celsius, centigrade, or whatever. I just put in some numbers. You know, you could use, maybe this is centigrade. It really doesn't matter. You might want to give some additional information, like saying in degrees C or in degrees F here. Okay. Okay. Now what I did is I just created a Boolean. Oh, sorry. I created here. Now these are just some constants I put in, or some initial values for the top temp, bottom temp, right temp, left temp, and tolerance. Okay. So what I did is I hard coded these in, because it makes it easier to go through and debug it. All right. Then the next thing I did was, these are all the prompts for the user. Prompt user for values. Okay. So that's what this is. And I have it commented out for now, but I'll put it in after I get through all the code here and show you how that works. Then I'll put this back in and then allow the user to enter these values in. Okay. So all these are just commented out right now. All right. The next thing I do is, this is my initialize array. Okay. This is a nested loop to do that. All right. So what this does is, what I do here is that I set the value of the top temperature, the highest row. So this is the first row equals top temperature of the top, right? Top temperature. And the reason I did that is because when we go through and calculate the average, and I did this for each of them, like I did the bottom row is temp bottom, the left column, right, J equal to 0 is the temperature on the left, and then the right column's temperature on the right. Otherwise, if it's not like on the edges, it's just 0. And the reason I did this is because when you perform the calculation, you need to have the value before it, above it, below it, and to the right, right? So where there would be a problem is along the edges, right? So you don't have any numbers for those. So what I did is I just took and populated, you know, the first row, you know, first column, last row, last column with values. That way, the calculations are easier. You could have done it other ways. You might have had a more complicated a function that determines where you are in the grid, and then depending upon that, determine, you know, what you should use for, you know, the left, top, bottom, or right values. Okay, I think this is easier to do it this way. All right. So this is initialized. Okay. And okay. So then all I do is this just says after initialization. This next for loop display the grid. So this is like display the grid after I initialized it. Okay. Then a couple of end lines here just to space things out. For spacing of display. Okay. And now what this does, this actually goes through, and this is like one iteration of the function called calctemp. And what this does is it loops, loop through until tolerance has been met. Okay. So when we look at the function, what you'll see is that if any of those differences between temperatures, when I'm saying tolerance, what I'm doing is I'm comparing the old temperature that was in an element with the new temperature that I'm updating each time I go through and iterate. Okay? So if all of those temperatures are within the tolerance, then I'm done. Okay? And that's what I'm passing back. Result basically tells you, oh yeah, everything's within tolerance, so you're done. You can end this loop. Okay? And then what I do here is just display grid, temperature grid, temperature grid, grid after, after it has, it converged after values have converged. Okay. Because as time goes on, what will happen is the differences each time you go through an iteration will get smaller and smaller and smaller. Okay. All right. So that's what this does. Just goes to this is the actual function call that performs the calculation of setting those new temperatures based on the averages. So we'll take a look at this function. All right. And of course, then I say display it. So this is at the end. Let's look at the function a little bit. So this is the function that actually performs the calculations. Okay. One thing here, actually, I modified this, so I really don't need, let me fix this. I'm going to get rid of all of this because I don't need this anymore. I don't even use it. The only thing I use is tolerance, so I'm going to do double DOL. Okay. So I need to modify it. I'm going to modify my call, function call here. Oh, no, tolerance is needed. So I'm going to change to this. Okay, that simplifies that. And of course, I need to do it one more place up here. Just this. Okay. All right, so this is now, and we should be good. Okay, so now this is the modified prototype, okay? Function prototype. All right, so this is what it looks. Here's my call now. Here's my function call. And here's my function header and the function definition, okay? So this is how this works. First thing you do is, okay, are we using over tolerance? Yes, we are. Okay, so first thing you do is I have a couple of variables here. One's called hold and one's called sum. And sum is just keeps track, basically just holds the value of the 4 elements that are around the element that we're trying to calculate the new temperature of, right? Hold is just temporary storage for the value, okay? Because I need to compare that, the hold. I'm comparing the hold with the new calculated value. Okay, so I'm carrying, this is like the old one. This is the old value that's stored in a cell, and I'm comparing it to the new one. And if that difference is less than the tolerance, then this is not going to evaluate out true. It's going to be false. Okay, so if it's over this, if any of them are over, even one, this thing sets to true, and now the whole thing becomes true, right? And then when it comes back out here, this will say true, and then it'll keep going. It'll run this again. So it keeps going, keeps going, keeps going until finally this evaluates out to false for all of them, every element in the array that I went through and looked at. Okay. So here's what I got to do. I need a nested loop. Okay. Now, one of the things you'll pay attention to here is it doesn't start at 0, it starts at 1. And the reason it starts at 1 is because I've allocated the first row to be row 0 to be that temperature, right? The set temperature that I said, the top temperature, okay? And then I said row -1 less than -1 because I set the bottom temperature to also be the bottom, called bottom temperature, right? Or the last row has the bottom temperature. This thing I called bottom temperature, right? Which is what the user is going to enter in, okay? So that's why it didn't go all the way to the end. And the same thing for the column. Here is, I use the leftmost column, which is j equal to 0. I use that column to represent left temperature, and this one represents the right temperature. The column just size or one less than it represents the right temperature. So I have to push it in by one more, okay? All right, so this just calculates the sum for all of those. And then I just take the old value here. Before I change it, I set it in, I save it. And then I calculate the new sum. Or sorry, not the new sum, the new average. Here's the average. It just took the sum, which was calculated here, and divided by 4, because there's 4 elements. All right? Then I compare it. And here's the comparison. So all I'm doing is just saying, oh, okay, if the difference, the absolute value of the difference, right, is greater than total, set this to true, right, which I talked about previously, which basically says, hey, we want to keep running this thing. Each time we want to run it through this loop structure until until this runs one time all the way through these, one iteration, which means go through everything all these times, goes through every single element, right? If this never comes out to be true here, meaning that this is over, or never meaning during that iteration, none of the elements are over, then it's gonna stay as false, okay? And in the end, we just return over tolerance, okay? All right, so then that is basically it. So now let's run it, and I'll show you it run. When you run it, here's the first time. So here's my grid, and you can see I set everything to the top temperature. This is the 100 that I hard-coded in. And these two don't, the corner ones really don't make any difference what they are, if they're the row or the column, because I'm not using those to do my calculations. I'm only using the ones around, so I'm kind of ignoring that, okay? So here's my 75, here's my 100, here's my 20, and here's my 50, okay? Now, after execution, you'll see here's the 100, here's the 75, 50. Those all stay the same. And then what you'll find is that, you know, between them, the temperatures will vary, right? So like it starts off at 20, goes to 39, so 39, 50. So this gives you like the middle temperature of those. And this will go up until you get to here, 75. And then this is 100. It goes down until you get to 50, right? Goes down, goes down, goes down, okay? So we can make the assumption that this works correctly. And we can actually we'll try some different numbers. And, you know, I think I'll just plug in like 0. This 0 is something else, not part of that. But I'll plug in some different values for the temperatures and see how they work. All right? Okay, so here we go. So I'm going to uncomment these so I prompt the user to actually enter these values in. Okay, so let me run these. Okay, enter top temperature. Oh, I don't know. Let's do 50, 50, 50, and 50. So everything should be 50. Enter tolerance, oh, I don't know, 0.1. Okay, so everything's 50 except these are really close to 50, so they came out to be 49 because I truncated them in their double data types. All right, so I think that's good. Oh yeah, because one thing I did do here, I put this when I display it. Where is it? Right here. I said it was integer data type. So maybe you want to do this, and then you can actually see it. So let me run it again. You can keep it as integer data type. That'll be fine. Casting it as an integer data type. But let's do this. So 50, 50, 50, 50, and I don't know, 0.2. Okay, you could see that these are getting really close to, oh, you know why it's a little different? It's because my tolerance. So if I make my tolerance a little bit smaller, I'll actually do a little better. So let me run it again. I'll do 50, 50, 50, 50.01. Okay, now you see you're getting really, really close. Okay, if I make that tolerance smaller and smaller, it'll get closer and closer. Okay, all right. Let me go back. I'll set this to, okay, I'll set this back, casting this back to an integer. Okay, and that should be good. So let me do some other temperatures here. Try one more set. Oh, you know what? Let me do one more thing here. Make this a little bit better here. Get a space there. So we can, I'll just put a space. I'm going to put a colon and a space. Colon space, colon space, colon space, colon space. Good. Okay. All right. One more time here. And I will save this on the, put it out on the source code, underneath the source code link on the website. Top temp, 10 degrees. Bottom temp, 100. Left, let's do 10. Right, 100. Tolerance, 0.01. Okay. So 10, 10, 10, here's 100. Of course, these are, these are the set values. This value really doesn't, like, I don't know, whatever this value is. It's not really significant in this one. This one doesn't make any sense because the way I defined it. You can check the author solution, see the author did, but what you can see here, this temperature is not valid. Okay, these are the ones that are, who knows what these are. There's something different than that. I didn't calculate those. So make a note of that. So you'll see what happens. It's 10 over here and goes all the way out to 100. Okay, and it kind of increases. Either way you go, it increases along this way and this way. All right, so that's pretty much it. That makes the basic requirements for this problem. Okay.